Let's start this. So yesterday, what was the main topics we discussed?
I've seen like symmetric, and
Okay, we have seen standard deviation and variance, right?
standard deviation and variance.
Okay, fine. So I was showing you uh, standard deviation and variance formula, right? So we also understood what is variance. It's the average of the square difference from the mean, right? So it will tell you like how much each data point is differing from its mean. Okay, and we also got the standard deviation, which is the square root of this. Fine. So now uh, one point, uh, if anybody of you is getting doubt, like when we already have variance, a parameter, right? Why we should have something called as standard deviation again, which is just the square root of that? Okay, why we are again squaring it? Fine, we have variance, right, which is rho square or s square. Fine. So you can use wherever it is required. You can, if you want to use square root of this particular value, you can directly make square root of this and use it, right? But why we are creating a new parameter itself called as a new measure itself called as standard deviation, and we are studying it. Okay, or why we are doing square root of variance, right? So the reason here is, if you see, if at all we are having initial data point, if there is some unit, okay, if there is some unit in variance, what we are doing, guys, we are doing square, in variance, in row square. What we are doing, we are doing square. That means what will this unit will happen, unit square. Okay, unit square. So the unit of the given data point is different from what we are getting in the variance. Agree? So to again bring back to the same units, we will do square root of rho square. We will get as rho, which is a standard deviation. So the reason is to make sure the standard deviation units are same as the original units. So if you are not getting by units, what I mean over here is, let's say uh, your initial value is meters height. If you're checking, guys, okay, height is your parameter which you are checking, okay, height of particular students in a room. So initially, what will be the height? So you will have 10 students. 10 students, if you have 10 students, each of them will have some height h1, h2, h3. Okay, like that. H10 will have, what will be the height parameter, guys? Right, let me consider as meter. Okay, just for example, let me consider it as meter. Fine. Now when we do variance of this, fine, what I'm doing here, I'm doing square. You will get some mean of this. You will get some mean of this. Let's say mean is h mean. Okay, mean is hm for all these 10 values. Okay, for all these 10 values, h1, h2, h3, let me say mean is h some number, I'm calling that as hm. Okay, now, sorry, now minus hm minus, okay, my point. Okay, if I consider h1, mean minus my value, whole square, by some n minus 1. Okay, we'll do n minus 1. But here, if you see, when I'm doing the square, what is the value of units of this one, guys? HM. This is also height, right? This is also height. This will be meter. What is this HI? This is also meter. Meter minus meter, some meter you will get. If you do square of this, the answer will be meter square. Getting in variance what's happening? So the units of the data points which you are considering is getting changed. Okay, but to bring back to the same units in standard deviation, what we'll do, we are just square rooting of the variance. So here, if you consider the units, right, you, square root of meter square will be meter again. Fine. So as you can see, the the actual value units and the standard deviation units will always be same, whether it's meter or square meter or feet or any type of value data points you take, right? The units will be same in the actual value and the standard deviation, right? To make sure these are the same, we have created standard deviation which is just the square root of this. But if you think why we are squaring, so if you think hey Santosh, why instead of initially squaring, getting some value, again doing square root back, why we can't directly go for why we should first of all square over here? Okay, because yesterday we have seen, to repeat, if we don't square this, what's happening? Some of the values, so what is mean, guys? Always, so we'll have some starting number h1 h2, right? So somewhere h10 you will have, hm will be where, somewhere here in the middle, hm will be there, this will be hm. So whenever I'm saying mean, obviously it's mean, it is average. That means it will not be the lowest number, it will not be the highest number, it will be somewhere in the middle number, right? So that means when I say middle number, what does that mean? It will have some numbers greater than this and will have some numbers less than this. Agree? So that means what? When I do this one, when I do each value, each hi minus hm, okay, when I do this, there is definitely 100% possibility that some of these values will be positive and some of these values will be negative. Agree, guys? Agree? Because when mean is in the middle, some when for all the numbers where mean is less than hi, it will be positive. If it is greater than hi, it will be negative. Agree? So what will happen? There will be some cancellation will happen here, right? If some value is minus 10 and some value here is plus 20, for example, so 10 gets cancelled and only you will have 10. That means you are reducing 10, the distance of 10 you are reducing. But how we can reduce 10? Because the distance is already there, right? The difference between that particular number and it is there. Just we have some distances minus 10, some distances plus 20. You cannot say the overall is 10. No, you should, this is also 10, this is 20. You should consider the magnitude itself. Okay, you should consider the magnitude itself, not the direction. So that's why, to eliminate this type of problem, right, to eliminate the cancellation of positive values from the negative values, we are first of all squaring it. Okay, so that every number will be considered definitely, there will be no cancellation. This will become 100, this will become 400, right? So you will keep on adding the values so that you have considered each and every distance. That is the reason initially you don't directly use the values, you'll square the difference and you will use the values. That is giving us variance. Okay, but since the units will get changed, fine, so to bring back to the same units, we will do the square root of the variance, which will bring back us the same units. Is this clear, guys? Did you get this, what I'm trying to say?
Yeah, Santosh. So here we should think like if we take a graph like from negative means left side and positive means right side, right? So we have to take everything. So then only we will get the mean. So that's why we are squaring
అంతే
it, right?
కరెక్ట్ కరెక్ట్ అంతే కదరా. సారీ,
Hmm.
అంతే కదా కార్తిక్. సి ఇఫ్ యు సి వాట్ ఈస్ మీన్, రైట్? సో నాట్ ఓన్లీ హియర్, ఎనీథింగ్ వాట్ ఈస్ మీన్? యావరేజ్ కదా. మీన్ అంటే
Average.
యావరేజ్. యావరేజ్ అంటే ఏంటి? యావరేజ్ ఎందుకు తీసుకుంటున్నాము? ఎందుకంటే ప్రతి దగ్గర మనకి మాక్సిమం వాల్యూ ఉంటది, మినిమం వాల్యూ ఉంటది. మనము మాక్సిమం వాల్యూ ఇప్పుడు యావరేజ్ కాకుండా ఉన్న దాంట్లో జస్ట్ మాక్సిమం వాల్యూ కన్సిడర్ చేస్తే ఇప్పుడు హెచ్ మినిమం ఏ నంబర్ ఎక్కడైనా హెచ్ మినిమం తోని స్టార్ట్ అవుతది. H1 ఉంటది, H2 ఉంటది. ఓకే. అలా మనకి హెచ్ మాక్సిమం ఉంటది. రైట్? ఇట్స్ ఏ డేటా సెట్‌లోనే మినిమం వాల్యూ ఉంటది, మాక్సిమం వాల్యూ ఉంటది. మధ్యలో కొన్ని వాల్యూస్ ఉంటాయి. ఇప్పుడు యావరేజ్ అన్నప్పుడు మనము మినిమం వాల్యూ చెప్పలేం. ఎందుకంటే మినిమం వాల్యూ చెప్తే వీళ్ళకి ఇంజస్టిస్ చేసినట్టు. మాక్సిమం వాల్యూ అని చెప్పలేం. మాక్సిమం వాల్యూ అని చెప్తే మినిమం వాల్యూ ఇంజస్టిస్ చేసినట్టు. సో అందుకే ఇద్దరిని బ్యాలెన్స్ చేయడానికి వి విల్ ఫైండ్ ఔట్ సమ్ వాల్యూ. సమ్ వాల్యూ మధ్యలో ఎక్కడో వాల్యూ తీసుకొని దాన్ని మనం హెచ్ మీన్ అంటాం. ఓకే. హెచ్ మీన్ అంటాం. కరెక్ట్. సో ఎనీ డేటా సెట్‌లో మీన్ అనేది మధ్యలోనే ఉంటది. అగ్రీ? సో మధ్యలో ఉంది అని అంటే ఆబ్వియస్లీ దానికన్నా కొన్ని నంబర్స్ గ్రేటర్ దెన్ అయ్యి ఉంటాయి. దానికన్నా కొన్ని నంబర్స్ లెస్ దెన్ అయ్యి ఉంటాయి. ఓన్లీ అప్పుడే ఇది మధ్యలో ఉంటది గదా! ఎందుకంటే ఇది ఈ కార్నర్‌కి ఉంటలేదు, ఈ కార్నర్‌కి ఉంటలేదు. సో ఆబ్వియస్లీ ఇది మధ్యలో ఉంటుంది. క్లియర్? సో అప్పుడు వెన్ వి యూజ్ దిస్ వన్ xi మైనస్ x బార్, రైట్? ఎవ్రీ వాల్యూ ఇఫ్ యూ స్టార్ట్ సబ్ట్రాక్టింగ్ ఫ్రమ్ మీన్, నీకు ఖచ్చితంగా సమ్ వాల్యూస్ పాజిటివ్ ఉంటాయి, సమ్ వాల్యూస్ నెగెటివ్ ఉంటాయి. అగ్రీ?
Yes.
కరెక్ట్. సో, అప్పుడు నువ్వు డైరెక్ట్ ఇలా చేసుకుంటూ ఎళ్ళినావనుకో, ఇందాక చెప్పినట్టు ఏమైతది? ఇది ఇక్కడున్న వాల్యూస్ కన్నీ ఏమైతది? చూడు, ఇక్కడున్న వాల్యూస్ అన్నిటికి xi అంటే xi మైనస్ x బార్. ఓకే. ఈ వాల్యూస్‌కి ఆల్ థీస్ వాల్యూస్ విల్ బి లెస్ థాన్ x మీన్, హెచ్
Like
మీన్
negative.
నెగెటివ్. సో, నువ్వు ఏ వాల్యూ ఇక్కడ తీసుకొని మైనస్ హెచ్ మీన్ చేషినా గూడా నెగెటివ్ వాల్యూస్ ఒస్తాయి. ఓకే. ఓవరాల్‌గా ఇప్పుడు దీనికి -10 అనుకో, దీనికి -5 అనుకో. అట్లా ఓవరాల్‌గా ఇవన్నీ -10 అట్లా నీకొక -50 వచ్చింది ఫర్ ఎగ్జాంపుల్. ఓకే. దాని తర్వాత ఇటు సైడ్ ఎవ్రీ నంబర్ ఈస్ గ్రేటర్ దెన్ మీన్. ఇక్కడ నువ్వు సబ్ట్రాక్ట్ చేస్తే పాజిటివ్ ఉంటది. ఇదంతా పాజిటివ్ చేస్తే నీకు సమ్ 120 వచ్చిందనుకో. నౌ ఇఫ్ యూ సమ్ థీస్ -50 + 120, ఓకే. నీకేమైతుంది? 70 అవుతుంది. ఓకే. బట్ 70 అనేది కరెక్ట్ కాదు. ఎందుకంటే వై వై బికాస్ మనకి ప్రతి ఒక్క డిస్టెన్స్ ఉంది చూసావా? ఈ డిస్టెన్స్ ఉంది, ఈ డిస్టెన్స్, ఎవ్రీ డిస్టెన్స్ యూ షుడ్ కన్సిడర్. ఓకే. నువ్వు ఈ 70 అంటే నువ్వు 50 అనేది మైనస్ చేస్తున్నావు. ఓవరాల్ డిస్టెన్స్‌లో నుంచి నువ్వు 50 అనేది ఇక్కడ మైనస్ చేస్తున్నావు. బట్ నువ్వెవరు మైనస్ చేయడానికి? ఆ డిస్టెన్స్ అనేది యాక్చువల్‌గా ఉంది. ఎవ్రీ పాయింట్ దేర్ ఇస్ సమ్ డిస్టెన్స్ ఫ్రమ్ ద మీన్. సో, వి కెనాట్ డూ యూ కెనాట్ క్యాన్సెల్ సమ్ డిస్టెన్స్ ఫ్రమ్ ద ఓవరాల్ డిస్టెన్స్. ఓకే. ఫర్ ఎగ్జాంపుల్ ఇది. ఇఫ్ యూ నాట్ గెట్టింగ్ హియర్, కన్సిడర్ ద కేస్ వేర్ ఇట్ ఇస్ ఎగ్జాక్ట్‌లీ ఈక్వల్. ఫర్ ఎగ్జాంపుల్ ఇక్కడ -50 వచ్చింది. ఇక్కడ +50 వచ్చింది. అప్పుడేమైతది? 0 అయితది. అగ్రీ?
Yes. Yes. Yes.
0 అయితది. ఇప్పుడు 0 అయితే కెన్ వి సే, "హే, ఐ యామ్ గెట్టింగ్ 0. దట్ మీన్స్ దేర్ ఇస్ నో డిఫరెన్స్ ఫ్రమ్ ఎవ్రీ పాయింట్ ఫ్రమ్ ద మీన్." కెన్ ఐ సే దట్? నో, దట్ విల్ బి స్టూపిడ్ బికాస్ క్లియర్లీ ఐ కెన్ సీ దేర్ ఆర్ మెనీ పాయింట్స్ బిలో మీన్, మెనీ పాయింట్స్ అబోవ్ మీన్. So there will be obviously some distance. So I'm doing some mistake. Okay, because I can clearly see there are some difference from every point from the mean, but overall distance I'm getting 0. That means there is some mistake from my end, right? That mistake is cancellation of this. When I can avoid the cancellation, okay, when there are all positive values, then you cannot do cancellation. To get the positive values, I will square. Now I will say, hey, I'll do square, I'll do square. That's fine. So then there will not be any cancellation. I'll get this, I'll get this. But the problem, I'll get the variance. Okay. But the problem is వేరియన్స్ చేసినప్పుడు యూనిట్స్ అనేది మారిపోతాయి. ఓకే. సో నీకు యాక్చువల్ వాల్యూస్ ఏదైతే ఉన్నాయో యూనిట్స్, ఇట్ షుడ్ బి ఆల్వేస్ ఇన్ ద సేమ్ యూనిట్స్. ఓకే. బికాస్ వీ కెనాట్ చేంజ్ ద ఇన్పుట్. ఫైన్. సో దట్స్ వై టు బ్రింగ్ బ్యాక్ టు ద సేమ్ యూనిట్స్ వీ హ్యావ్ created some other measure called as deviation, standard deviation, which will do the square root of that so that it will bring back to the same units. Clear, guys? Why what is variance, what is standard deviation, and most importantly, uh, like why we are using some other measure called as standard deviation when we already have variance, right? ఎందుకంటే you will not see anywhere in max, suppose if you're having some parameter called as uh, some parameter, okay, which is uh, square of some number, okay, which is square of some number x square, then you will not find any other number, any new parameter which will say this is square root of x square. Okay, there is no need to create one more parameter, right? Because wherever it is required, you can simply do square root there only. In the equation only, you can do square root x square. You don't need to create a new measure with the square root. But here it is happening, right? Because to match the units. Fine. So this is just theory behind that. Okay, so just for your understanding background purpose, in case if someone asks you in some interview. Okay. Okay, but understanding what is variance and standard deviation should be important. Fine. So I hope you got clear picture of what is variance, what is standard deviation, right? uh, may I know, is that clear, guys?
Yes, sir, clear.
Okay, fine. So now what we'll do, we'll see an example. So where yeah, this will be helpful. Okay. See, now for example, if you see, let's take one example and try to understand the standard deviation. Okay. See, these are the scores. Okay, these are the scores of two batsmen. Okay, let's say Rohit Sharma and let's say this guy is Virat Kohli. Okay, just as an example. Now, in 10 matches, these are the scores. And this is a sum of all 10 scores for Rohit Sharma, and this is for Virat Kohli. And this is the mean for Rohit Sharma, mean of Virat Kohli. Agree? So, if you see, what is mean, guys? Sum of all numbers. This is, that means sum by total, right? Mean is what? Sum by total. Now, what is total? Total is 10. Sum is 510. That's why 510 by 10. You will get 51. Agree? 5 that 435 by 10, 43.5. Clear? How did they calculate mean? Simple, right? Sum by average. Now, by seeing this data, if I ask you to pick one batsman who is better among between both of these two persons, you might say, or anybody will say, the mean of this Rohit Sharma is obviously greater than, okay, obviously greater than Virat Kohli, right? So obviously this guy should be the better person, better batsman. Okay, but that is fine, that is completely fine, anybody will think like that. And that's how a normal guy should think, because you cannot say, you cannot consider each and every value. You cannot consider each and every value, right, for from both the batsmen, right? Obviously you should have some single number to represent all the numbers, right? Yesterday we are discussing this point. So mean is that score which will help us to represent all these 10 numbers, all these 10 numbers with one number. Okay, similarly all these 10 numbers with one number. Okay, so now we got these two numbers, and by looking at it, we can clearly see Rohit Sharma's average is much better than the Virat Kohli. So Rohit Sharma is a good, better batsman than Virat Kohli. Okay, that's perfectly fine to say, okay, for a normal guy. But we as statisticians or persons who are studying statistics, okay, should go a step deeper, okay, to understand. So can we directly depend on mean and decide whether, if the mean is greater than the other person, he should be the better batsman? Can we take only mean as the measure of performance? We'll see. Fine. So now you will understand the concept which we have studied, standard deviation, variance, etc. Okay. By seeing the above data, we can say that batsman 1 is better than batsman 2 and can be given preference. And since its mean is greater, but is it really true? We'll try to check. So initially, let's check the variance, and also let's check the what? Standard deviation. Okay. Now to check variance and standard deviation, what is the formula, guys? The formula is this one. So xi minus x bar whole square, right? That means calculate the difference of each and every point from its mean and do the difference. Fine. So the same thing we are doing. So batsman 1 score, batsman 2 score. Okay. Difference from its mean. Okay. So what's happening over here? So each and every value, this value is getting subtracted from its mean. That means what is happening? Xi minus x bar. Okay, what is x bar for batsman 1? 51. Okay, so x bar will be 51, so this will be 51. And what is the actual value? 54. Okay, 54 minus 51, or he's doing x bar minus x1, anything is fine, because we are going to square, right? So if I do x bar minus xi, see, x bar minus xi, so x bar is 51 minus what is actual value? 54. Fine, what is this value? Minus 3. Right, next one is 35. Right, so x bar will be same, x bar will be always 51 because that is a mean, minus 35, that will be 16. Agree? 16 minus 3, right? Next 68, it will be minus 17. So this is the difference. So difference 1 is the difference of each and every value from the batsman from its mean 51. Agree? Similarly, difference 2 is the difference of each and every value from its mean 43.5. Okay, that's why 43.5 minus 45, initially we'll have minus 1.5. Okay, so this is for this. After that, once we get the difference, what we need to do, guys? So we need to square. Fine. So now, as you can clearly see, the difference is minus 113. Okay, so here you are having some minus values, some plus values. If you directly sum this, right, you will have some cancellation. So that's why you are squaring. So minus 3 square is 9, 16 to 56. Okay, for every difference one, the square value is this. Okay, and for every difference 2, the square value is this. Fine. So what we have done, so same thing, this one, square difference from the mean. Fine, square difference from the mean. So this is a difference and this is a square difference from the mean. Fine. So after that, after that, what we need to do? The average. The overall variance is square of the difference from the mean. We have done the difference, we have done the square. Fine. Now we will just do the average. Average is what? Divide by the number of counts. So the variance you will get by, see, this is this value. If you divide by the average, that means the total number of values, you will get the variance of batsman 1. Okay. Standard deviation, how you will get? Just square root. If you do square root, you will get the standard deviation. Fine. Next, coefficient of variation, how you will get? See, yesterday at the end of the class, I was mentioning you one parameter called as coefficient of variation, which is simply the standard deviation by mean. Agree? So we know the mean 51. Now we know the standard deviation 56. If you divide 56 standard deviation by mean 51, you will get this. Clear? Fine. Till here. For batsman 2, this is a square difference. If you divide by its mean, you will get this one. Standard deviation is square root of this. Just square root of this is standard deviation. And dividing this by its mean is 43.5 above. Right? So that is this. Okay. Clear? So we will see, but as we have seen this example, right? So I think you will be in a position to calculate the variance and standard deviation manually for any given data set, right? Obviously, you have Python to do that. Okay, you can do it in a single line of code. Okay, but while studying, you should also know how you can do it manually, right? So obviously, you can. I hope you can clearly do all these steps if required manually also. Right? Fine, with a pen and paper. Just simple. Take number, do this difference, square root, and square root. Okay, so that's a variance and standard deviation. Now, if you see, it's very interesting to observe the values here. The variance of this guy, fine, see, observe closely, guys. The variance of batsman 1, if you see, it's 3168. Fine. But the variance of this guy is 465. Agree? So, and all the other numbers will be the same. If variance is, see, if the variance is high, the standard deviation will also be high because it's square root, and coefficient will also be high. If variance is low, its corresponding standard deviation will also be low and its coefficient of variation will also be low. Agree? So, but the important point here is to see the variance of this guy. You can clearly see the variance of this guy is this much and variance of this guy is very less. But what does this variance is trying to say? That is important. See, what does the variance is trying to say? For first guy, batsman 1, it is how much, guys? Let me take roughly 3000. It was 3000, right? For batsman 2, it is 400. Agree? If you see, yeah, it is 3000 roughly, and this is 400. Fine. So what is this trying to say? It is saying that means each and every value. So what is this variance, right? This is variance. What is the denotation of variance? Rho square. Okay, rho square. Okay, so try to understand the meaning. What does this number is trying to say? Okay, formula is fine. If you put the values, you will get the value. That's fine. But always try to understand the behind the meaning, right? What is it actually trying to say? From where you are getting the variance? Variance is nothing but the difference of each and every value from the mean. The difference of each and every value from the mean. Agree? Same thing here. The variance is, you're doing square, you're doing square root, that's fine. But fundamentally, what is that? Fundamentally, you will have some mean, and it is actually the difference of each and every value from the mean. Do you agree with me, guys, to this point? This point?
Yes, Santosh.
Now, if you see, when you are having high variance, what does that mean? That means each and every value, okay, each and every value are very much different from each other. Agree? Each and every value are very much different from each other, or the overall spread of these values is very, very large when compared to these numbers, right? Only then you will have a so much big uh what do you say, so much big variance, right? See, mathematically, if I speak, what is this? Xi minus x bar whole square is just the variance. Agree? Either for this also, either for this also. If you see, for every value over here, x bar is same. Only thing that is going to change here is xi. Okay. So if xi values are very much far from each other, very much far from each other, okay, then what will happen? This value will keep on increasing. Getting, guys? For
Yes.
example, if I have 10, first value 10, 11, 12, simply, okay, this is 16, 17, for example. Okay. Now, if I say 13 is the mean, 13 is the mean. Okay. So now, if you see this, okay, if you see this, what will happen, guys? 10 minus 13, 10 minus 13, how much?
Minus 3,
Mi-
minus 2, minus 1.
okay, small numbers, minus 3 whole square plus minus 2 whole square plus minus 1 whole square, right? Plus here some 2 square, okay, plus some 4 square, okay, something like that. I- okay, if the numbers are very much nearby, you will have the difference between the mean from that number will also be somewhat, all these values will be almost nearby each other. Okay, that means 3 square, 2 square. Okay, but if the values are like this, 1, 10, 16, okay, okay, 110, okay, considering it's with the same mean, we'll say, considering the same mean, if we say, if we take 1, okay, some 6, fine. Again, if it is jumping to some directly 12, fine. And if I have some 33, and if it goes to 54, okay, instead of these values, if the values are like this, okay, and if you try to now calculate with the mean, if you try to calculate the values with the mean, so now what will happen? 1 minus 13 will be minus 12. Getting this?
But Santosh, your mean will change, right? Based on new numbers.
Yeah, that's a good point. I agree, that's a good point. Mean will change, but even if you consider for the same mean, even if you consider for the same mean also, the values, if you are considering a very nearby values, okay, so that's perfect point, I understand. But what I'm trying to say here is, the mean, whatever the mean, whatever you are getting over here, okay, if that mean, if you are getting from the values which are very close by each other, okay, fine, I understand your point. Okay, fine, let me take a number. Okay, let me take a number called as just like 1, okay, 6, and what we'll have here, I took 12, okay, what I took here 33, okay, and I took here 58. Okay, now to these numbers, what could be the mean? Let's say something around like 24 something. This is an example, some middle number for this. Agree? Or are you calculating?
Calculating.
Okay, fine, do. Tell me just rough number.
Yeah, 21.2.
Okay, 21.2. So now if you see 21.2, okay, now what will be this 21.2 minus 2? 20 square. Okay,
Yes.
some roughly, and this will be if I consider 20 roughly, 20 minus 6, what will be 14 square? Agree? And next 8 square. Agree? And this is some what will be 13 square. Okay, and next will be what? 38 square. Fine. Now see what's happening over here. In the first case, the mean is, in the first case the mean is 13. Fine. In the second case, roughly the mean is 20. Fine. So now I'm saying, if I I agree to your point. So the mean is different, but even to this scenario, if you consider, if at all the whatever the mean which you are getting over here, and if the points are the mean which you are getting over here is created from the points which are closer to each other. Okay, so the 13 is created from which points? 10, 11, 12, 13, 16, 17. Okay, 13 is the mean. Okay, 10, 11, 12, 16, 17. From these points this mean got created. Okay, and the numbers, if they are very closer to each other, like 10, 11, 12, obviously this value, the overall variance will be low, right guys? If you see this value, if you are having it, let me call it as some x, and if there are some other set of numbers like 1, 6, 12, 33, 58, which are very far from each other, and obviously these numbers will also have some mean called as 20, right? If you are calculating the variance of this, if you have this as some y will be very much greater than x. Agree? So these numbers, as you can see, if you do calculate, y will be very much greater than x. Do you agree to this point?
Yes.
Clear? Meghana, you are following, right?
Yes, sir.
Or did you like lose track anywhere?
Okay,
Okay,
following.
fine. So that's what I'm saying. So here, if you see, for every set of numbers, any set of numbers, guys, you will have a mean. Obviously, it is just taking the average. And once you have the average, obviously you can find out the square difference and you'll find out the variance. Okay, you will have the variance. So fine. But if the variance is high, what does internally it is meaning? It is meaning that the original numbers, whichever are there, they are very different from each other. Agree? Only when they're very different from each other, then only you will have these values, the square values will be high. Only the overall sum will be also very much high. Agree? But if the original values are not very much different from each other, they will be very nearby. Fine. So then the difference from the mean will be also very much less compared to others. Fine. So then obviously you will have the overall value will also be less. Fine, because from where we are getting simply x bar xi minus x bar itself, everything will boils down to this formula, xi minus x bar. So this if this x bar is remaining same, but if x is not changing much, right, then obviously this value will also not change much. Fine, that's a single point you need to understand. That's it. Fine, xi minus x bar is the whole sigma that is happening over here. Okay, whole square is happening. So if for a given data set, x bar will be constant because that is mean. The only change that is happening is x bar every time. New 10, 11, 12 like that. Fine. Now if xi is not changing very much, it is that, then obviously this value which you are going to get every time will also not change that much. Agree? So for 10 you might get some value. For 11 you might get a little better value. For 12 you might get a little better value because xi is only changing little. This value will also change a little. Okay, so 1 square, 2 square, 3 square. But if xi is drastically changing every time, that means from 1 it is shifting to 6, 12, 33, 58. So obviously the square value will also change drastically. Agree? You're seeing what I'm saying? So that's why you are getting right, Karthik?
Yeah, yes, Santosh, I can
Yeah.
understand.
So that's why the fundamental point which I'm trying to say over here is, if the way overall, so if I just, yeah, I just remove that. Yeah. So overall now we had batsman 1 is 3000. Okay. Batsman 2 is 400. So that means clearly I don't know what are the numbers. Okay, that is now beauty of this formula. I don't know what are the, even though you don't know the numbers. Okay, now we have calculated, but someone has told you, give a calculator and just told you, hey, batsman 1 variance. Okay, variance is this. Okay, batsman 2 variance is this and batsman 1 variance is this. Okay, simply with this number you can try to understand, hey, variance is very high. That means what? That means each and every value is differing from one another. Only then the difference from the mean will be very much high. Only then the square of all those numbers will be very much high. So that's the reason variance is high. Here the each and value is not differing from each other so much. That's why the variance, the difference from the mean is not that much changing. So obviously the square will also not change that much. So the if you sum the overall numbers, it will be a small number. But here you can see the maximum number. Agree? So from this, what we can conclude here is, since the variance is high, the values are very much different from each other. What does that mean? That means there is some inconsistency. That means what? If initially if he's scoring 10, after that if he's scoring 50, after that if he's scoring some like 90, again he might score some. No need always the number should increase, guys. I am showing 1 2 3 4 5, but no need to always have ascending or descending order. So again you might come back to 20. Fine, batsman 1, this is for batsman 1. Fine. So as you can see, the numbers are varying so much from each other. Again he might suddenly shift, he can hit a century. That's the same thing with Rohit Sharma, right? Exactly. This is what he does. Sometimes he will do extremely low square, sometimes he will be duck out, sometimes he will score. In the previous match he has scored some 131, right? So he will again, sometimes he can go to 30. So the variance between the numbers, the difference between each numbers is extremely high. So that's why if you calculate some mean, I am guessing somewhere if it is 60, so it will be very much high, because the difference from each and every number is actually high. But if you see, come to Virat Kohli, like batsman 2, the variance is somewhat not that high. So obviously it could be like 30. Sometimes if you do make 30, next you go to some 35, to 40, 42, like 55, something like that. Okay, if you take some averages, some 41, the difference from each and every number from this mean will not be that different. This will be 10, this will be 5, 1, 2, something like that. So the overall sum will also be, you are getting a small number as just 400. But here the overall difference, as you can see from each score, that means in one match if you do this, in some match you will jump to somewhere else. So there is constant shifting between the values, which is creating a difference between each and every value in the data set. And that is resulting directly in the high square difference, which is directly resulting in the high variance, which is 3000. Clear? So now that's the reason this guy is having 3000 score, this guy is having 400 score. That means variance. Fine. So from this, what we can understand, the difference is between the value is high. That means inconsistency in this. So if you take the practical, if you want to say it practically, what we are trying to understand, that difference between each and every value is very much. So that means this is high inconsistency. But here there is consistency. Here consistency. Fine. So that's why now if you go back initially by looking at it, batsman 1 score is 51, batsman 2 score is 43. Fine. So batsman 1 score is this guy, this is variance, guys. This is a variance. Fine. This is also variance for batsman 2. And what is the mean? Mean of second guy is 43, this is 51. Okay, but for this guy mean is 51. Okay, this guy 43.5. Fine. So normal people might think, hey, mean of this batsman 1 is high than this guy. So that means he can think that, hey, on average, it is obviously it's common sense to think, right? Hey, on average, this guy is doing very much better, because mean is what? Mean is just average. So overall 10, if you take the average of 10 scores, 51 is very much greater than 43.5. So obviously I can go with the 51 and consider this guy as the best batsman. That is a normal guy thinking. Okay, but since we are studying statistics, we should go one step deeper, and we understood the variance, we understood the difference, and we understood the standard deviation, right? So from that point, if you can see, the variance of this is very much high than this guy. So there is complete inconsistency, right? There is so much difference. So when I say complete inconsistency, what will happen? That means if I want to decide for the next match, very important match, if I want to go decide like whom to send, whether Rohit Sharma or Virat Kohli, right? Virat Kohli, fine, whom I will send. I will go for Virat Kohli, because even though he is not scoring, let's say, because if you can see, there is no 100 in Virat Kohli, right? So even though I know that Virat Kohli might not be scoring a century, but still I will go with Virat Kohli because there is some consistency, right? I'm sure at least he will do 40. I will do at least he will do 42 runs. That's fine for me because it's a very important match. I don't want to get duck out. But if I go with Rohit Sharma, even though the mean is high, I cannot go because the variance is also high. That means what? The difference between each and every value is high. That means suddenly he can come to zero also. That's my point. Fine. Suddenly he can come to zero or some single digit because he's completely fluctuating the value. His variance is very much high. His standard deviation is very much high. Fine. But Virat Kohli, that's not the case. His variance is very low. That means he will not vary. In simple words, when I say variance, he will not vary between his scores very much. Okay, he will be nearby some bracket of 30 to 70, something like that. Okay, so at least I am sure, okay, he will give me 30 runs. That's fine for me because it's important match. But the bracket of Rohit Sharma might be 0 to 100, right? This much is a variance. We can conclude this concept with this point, right? 0 to 100 is a variance. So that means he can go by 0, he can go by 100. I am not sure if it goes 100, that's fine. But if he can also go to 0, that's difficult. Fine. So now with this understanding, instead of blindly going with the mean and considering this guy as a best batsman, we can now take a complete overall 360 degrees picture and understood this variance is very much high. So we can disqualify guys. Hey, you are inconsistent, man. I cannot trust you. But this guy with little variance, I can say this guy could be trustable and because of his consistency. And in a way, we can also tell Virat Kohli is a better batsman than Rohit Sharma. Getting guys? Are you able to understand honestly the concept which we're trying to study?
Yes, sir.
Understood, right? So now I think next time you'll not directly blindly go with the mean, right? So now you have the enough knowledge to calculate the variance, calculate the standard deviation, understand what if high variance means what, right? So just observe here, high mean is fine. So if you're having high mean, that is wanted. Okay, everybody want to have high mean. Okay, high average overall, but high variance is something problem. Okay, so we always want low variance. Okay, the variance of should be low. That means he's not varying so much in his values. Fine. So in this particular case, fine. So the variance here, high variance is a problem. Fine. So with that concept, so if you see, since we calculated, we can clearly see that the standard deviation gives a different picture from both the batsmen. Though batsman one has high average, but his variance is also very high. So batsman one is less reliable. On the other hand, batsman two low average has low average, but is more consistent than batsman one. Okay. Similarly, if variance is same thing what we have discussed with variance, you can simply extend to standard deviation also. Okay, standard deviation also same thing will happen, and coefficient of variance will also be less. Okay, using any of this parameter, you can conclude what we have concluded because all these are interrelated, right? So if you can calculate the variance, that's the square root of that will be standard deviation. You can take this also as your arguing point. Standard coefficient of variation is also same. What is the standard deviation by mean? Okay, so if one is less, everything will have a direct impact. Fine. So that's a concept. So if you had only yeah, this is the point. If you had only taken mean into account, we would have not gotten the true picture. The problem is solved by this dispersion measures. Okay, what are the dispersion measures, guys? This standard deviation, variance, coefficient of variation, all these are called as dispersion methods. Fine. Fine. So now if we just try to see a few examples, what is the variance and standard deviation of possibilities associated with rolling a fair dice? Okay. So if you are just rolling a dice, guys, so what does dice will have 1, 2, 3, 4, 5, 6. If you roll a dice, only these are the possible outcomes. Fine. And what is a mean? Mean is just sum of these numbers by count. So sum by count 3.5. And what is a variance? Variance is what? Subtract each and every value, like 1 minus 3.5 whole square, 2 minus 3.5 whole square, subtract and do by mean value. 6, you got 2.917, and the standard deviation is 1.71. Fine. So this is just calculating. They've given a set of values, how you can calculate the mean, how you can calculate the variance, how you can calculate the standard deviation. Fine. And this standard deviation we will see in some more detail in next concept. So where we'll actually understand what a standard deviation also mean. Okay, I think now we got a better picture like what a standard deviation is trying to tell us. But in actual distributions, right? So when we have some distributions, let's say some symmetric or normal distribution, we'll also see what a standard deviation will tell us. Okay, and same thing, the following data set has a mean of 14.7 and the variance of 10.02. Okay, so this one, okay, see there are two values skipping. but he's saying the mean is 14.7 and the variance is 10.01. Fine. So can you compute the values of A and B? We know the formula, right? So the sum of the overall sum by the count will be 14.7, and the variance is A is 33. You got an equation. So there are two unknown values. So you need two equations to solve. Fine. So one equation you are getting from the mean, and the second equation he is also saying variance. Okay. And the variance is formula, you know, the difference of every square. So if you compute that, you will get one more value, one more equation, A equal 33 minus B. So uh, yeah, so this is one equation and this is one more equation. So if you substitute either this in this or this in this, you will get converted all into A's or B's, and you have the value of A and B. Clear, guys? Just this example, right? So just this mathematical expression in school we have solved, right? They will skip one value and you can calculate with the formula. Okay. So yeah, this is the standard deviation and variance of the population of the sample data. So yesterday we have clearly seen what is for population, what is for sample, and also I try to give an intuition why we are doing in over here, why we are doing in -1 over here, right? So that is related to what concept, guys? Can anyone just remind me why we are doing n and n-1? It is related to what concept?
Population and sample.
Yeah, population and sample only. When we are doing for population, we are doing n. For sample, we are doing n-1. So it is related to what concept? Yesterday I've spent some time to make you understand like why we are doing n and n-1. Do you guys remember, any one of you?
Uh, okay. COV or CD something.
Huh? Did we discuss COV, CVO?
Wait. Degrees of freedom.
Right. Okay. So degrees of freedom. You remember, Meghana, or you forgot?
Yes, I remember. For sample, we do not take all values.
What? For sample, we don't take all values.
And some sample of values we will take. For that, we consider degrees of freedom, said yesterday.
Correct. So for sample, we will use n-1 or n.
For sample, n-1. For population, n.
Right. Right. So same thing, the population n and sample is n-1. Okay. And why we are considering an n-1 is actually related to degrees of freedom. Okay, as we have discussed today. Fine. So the after that the concept will be covariance and correlation. Fine. So I'll stop over here because series is also not there. Fine. So fine. So and actually tomorrow there is no class, guys, because since we started the stats, right, I don't want to rush. Okay, too many concepts in a week. Okay. So I'll give you some time, 2 days, so you can go through the classes or start making notes. As I said, for stats it's very important to making notes because you will easily lose track. Fine. So in class, if I teach like 100%, you might get like 80 to 70%. That's fine. But if you don't revisit the class or make some notes from any other source, right, so you will easily lose track, and after 10 to 15 days all this concept will just wipe off from your mind. That's for sure. Fine. So because these are very new concepts, right, and these are not like very like normal topics which you see in everyday life, right? So these are some new concepts from separate branch of max, right? So I highly recommend, since you're spending so much time and energy, right, so if you don't want that to be wasted and if you don't want to rework, right, so just start making notes whatever you understand, or if you do not understand, just keep a heading and leave that page and go to next topic. Sometime back you can, so after some time you can come back and try to gain some more knowledge, right? But making notes will extremely help you, and it will directly help you in the interview time, which has happened with me. So I'm just advising you guys. Fine. So with that, we studied the standard deviation. So yeah, so tomorrow, no, sorry, we'll again meet on Monday. Fine. And then we'll start understanding covariance and correlation, and fine. There are next we are going to enter actual the fundamental, the main important concept in stats is actually to study about the distributions. Okay, what all we are trying to study this, just leaving, if I just want to give you one point. So why we are studying all these, we are just studying because in machine learning you'll be working on some data, some tables, some columns, right? Each column is data c1, c2, c3. So if you take this data, So yesterday we have understood what is a mean, what is a median, and what is a mode. Why we understood one application. Not only this, but one application is for the missing values, as I said. Okay, if it is symmetric, we can fill. If it's not symmetric, we can fill, right? So just to test, I will ask like Meghna, can you tell like if it is symmetric, what values I can fill it with, mean or median? And if it is asymmetric, what values I can fill, mean or median?
So I didn't understand your question.
No, I'm saying yesterday we have discussed symmetric and asymmetric distributions, right? So, and when I'm teaching the mean and median, so I told you that this can be used in filling the missing values in a given column. So if the distribution is symmetric, what values I can use to fill the values? Can I use mean or median? If it is asymmetric, what values can I use from mean and median?
For symmetric median.
Okay. For asymmetric, mean.
Maybe.
Yeah, wrong. That means you're not revisiting the class or making notes, but don't do that, because that will you will lose. Because yesterday I said in symmetric, what will happen? The mean and median will always be same. The mean and median will always be same. Fine. So you can use anything. But in asymmetric, you cannot use mean. Why? Because what is asymmetric means, the distribution is not symmetric. That means you will have some like this distributions. So in this case, clearly the mean will get affected by this and it will shift towards this skewness. You remember the word skewness we discussed in detail? In asymmetric, why it's called asymmetric? It's called asymmetric because it is having some skewness. And whenever there is skewness, mean will try to shift towards that. Agree? So that's why it is not reliable. Agree? But the median is robust. We have seen the diagram also, right? Meena? So I've shown you these diagrams. You remember?
Yes, I remember.
Fine. So as you can see here, the black color is the mean. So that is always shifting. The black color is the mean. That is always shifting. So that's why this is not every time reliable. The mean, mainly in the asymmetric situation. Fine. So in asymmetric, the median is more robust. Fine. So median is most robust. So that's why median should be used in the asymmetric mostly. But in the symmetric, you can go by the anything. Fine. So yeah. So that's why I am advising you to start making notes, the important points, right? So when you start making notes, and once in 10 days or every weekend, if you start revising those notes, so you will remember these points. Okay, that's fine. So, since we discussed just yesterday itself, that's fine. So it's not that easy to understand these points, but I'm just advising you, Megan, to start making notes, because soon you might start attending the interviews, right? So that's just an advice. Okay, so now coming back to this one, so as I said, we are going to study about the mean median, right? So to the further, and coming to this also, the standard deviation and the distributions, right? So for each and every column, you should know what type of distribution it is falling into, whether it is normal distribution or normal distribution, peak distribution, some skew distribution. You should know about each and every distribution, right? So that's why once we are done with this concept, the main concept which we are going to enter is called distributions, probability distributions of each and every column. Fine. So with that, we will be like studying the core concepts of stats. Fine. And then we have few more concepts. Yeah. But that's fine. So don't worry about these concepts. So try to make sure you are understanding what we have studied till now. The basic inferential, differential, mean, median, standard deviation. Fine. Variance. Okay. Make sure you are good with this concept. At least on the weekend, spend some time. Make sure you are very good in these concepts, so that I will take care of rest from Monday. Fine. Are we good, guys?
Yes.
Okay, fine. Sounds good. Chalo, take care. Let's meet on Monday. Bye.
Thanks.